You doing okay, beta?
Yes, sir.
Good, beta. And Chavi, beta, how are studies? How are your studies coming along? I assume that you have some microphone issues going on. That's okay. So let's start. So today we want to cover 4 question types on projectile motions. And this time we will have, especially number 38, 39, we will be dealing with the relative velocity concept. So that should be interesting. Anyway, we'll start with number 37. So what do we have in 37? It's in the continuation to what we discussed yesterday.
Excuse me, sir.
Yes, Peter?
You are presenting your screen.
I'm not presenting my screen. Give me a quick second. Let me present my screen. Okay. Hope you guys can see it. So once again, I'm talking about number 37. Let me get inside number 37. So what do we have here is we have 2 projectiles which are thrown at around the same time or at given their time difference, and they travel in opposite directions. So let's say one projectile is moving from left to the right, the other is moving from right to the left, and then they collide midair. And then you'll be asked to determine the unknown using this information. So let's do a quick understanding of how to think about such questions, and then we'll do a trial question. Or we'll do a good question, actually, not just a trial question. So let's say the 2 projectiles are thrown up in the air from the ground level itself, both traveling in the opposite directions. So assuming that both have been thrown at the same time, what does that mean for their vertical velocities? Well, we know since they are meeting together at some point, what does that mean? That they have both covered the same amount of vertical distance, or vertical displacement is the same in the same time. So can I then say that the 2 velocity components are the same? Can I make that assertion? So once again, if 2 projectiles are launched at the same time, let me call this as projectile 1. This is projectile 2. So they are both launched at t equals to 0 with initial velocities v1 and v2. And they meet at certain point in their flights. So can I make the assertion, can I make the claim that if the angle here is theta 1, this is theta 2, can I say v1 sine theta 1 is equals to v2 sine theta 2? Can I make that claim?
Yes, sir.
Okay. So what about the scenario wherein one particle is actually climbing up, the other particle has gone to the peak and then coming down? Will it be true in that case? So once again, their vertical displacement is the same in the same amount of time. Then let's call it h instead of y. So what is the equation we have? So what we are saying is for projectile 1, for projectile 2, h is equals to v1 sine theta 1 times t minus half gt square. And for the other also we have h is equals to v2 sine theta 2 t minus half gt square.
सो तो इसमें भी दोनों इक्वल होंगे.
Looks like it. Looks like it both should be the same. Okay, so that means the vertical component, the vertical velocities must be equal for them to collide at time t. But caution is, this is only true if the two are thrown from the same height. What if the two are thrown from different heights? Let's say one is thrown from here, another is thrown like this. This one is horizontal. So in that case, or in this kind of scenario, we obviously cannot say that their vertical components are the same. But what can we claim? Well, let's say they meet at certain point. That means that the vertical displacement, which may be different for the two. In this case, the vertical displacement is h1. In this case, it might be h2. And if they are thrown at the same time, then the time of the time of flight would be the same before collision. Okay, so the rest is you just need to write down the equations for both the projectiles, projectile 1 and projectile 2. And if you are given this distance, then you know that the distance covered by the first one plus the distance covered by the second projectile, sum of these two will be equals to d. So using this information and using the kinematic equations, let's go ahead and solve a sample problem on this question. Okay, so let's go ahead and solve this one. Number 56. So let me read through the question. It says, two particles are projected simultaneously at point A and B from two towers as shown in the figure. The two towers are 30 meters apart. Their heights are also given. If they collide, then the value of alpha is the angle of projection of the projectile B. It says if they collide, then the value of alpha is A into 10 plus B in degrees. Then find the value of A minus B. And what other information has been given? It says neglect any type of frictional force acting on the particles during the motion and take G as 10 meter per second square, where A and B are positive integers and both are less than 10. Both are given to be less than 10. For students on YouTube, so let's say they meet at certain point. Let's say the coordinates are x, c, y, c. And then if you pay attention, then the sum of their horizontal distance, the sum of the horizontal distance covered by the two particles or two projectiles must be equals to 30 meters. And the sum of their vertical displacement should be equals to 40 meters, right? Sum of their vertical displacement should be equals to 40 meters. So I'm going to go back into the live class now. Um, so let me just make a small correction to the statement I just made. In the vertical direction, the difference of their displacement should be equals to 40 meters. The difference in the displacements. Now, what I have shown here is I've shown that YA actually is the displacement of A is negative and displacement of B is positive, right? So now if you think of YA minus YB, now what would that mean? That the YB is positive and YA is negative. So their sum in that case would be 40 meters. In any case, if it did not make sense, don't worry about it. As we try and solve it, it will make sense. Yes, Peter, how are we doing?
Sir, I'm getting the same result, but इसके आगे कैसे proceed करना ये समझ नहीं आ रहा.
So you also have sine 53 plus alpha as minus 7 by 50.
Yes, sir.
सर वही सर ट्रिग्नोमेट्रिक आ रहा है उसके बाद नहीं हो रहा.
But till this part, you guys, you all had the same result, huh? Minus 7 by 50. So can I write this as sine of 153? Sorry, sine of 180 plus 53 plus alpha is equals to 7 by 50.
Yes.
Sir.
Yes, Peter?
Sir, sir, I'm also getting a similar thing, but it's not like I did not reach till here. Like I'm getting is 25 is equal to 4 sine alpha t plus 3 cos alpha t. Uske baad, I don't know.
So what did you have, Peter? 75?
25 is equal to 4 sine alpha t plus 3 cos alpha t.
So you had 25. So have I made any mistake here? Let me check, because that would make sense. For 25, what you must have had is, so let's quickly revisit our equations. So Chikabida, did you get the same thing as Chavi, or did you get what I wrote down as 7? Because there's a minus, there must be an issue of minus here, right? Because Chavi is getting it as minus 16. So that's why she's getting 25, because if it's 25, then it's fairly simple and straightforward. So Chavi, from here, do you know how to solve it? So let's go ahead and use the result that you have, Peter, and let's figure it out. So 4 sine alpha plus 3 cos alpha is equals to 25. If I divide by, is that what you have, Bida, or did you have 40 sine alpha plus 30 cos alpha equals to 25?
So, no, so 4 and 3 only.
4 okay. That cannot be the case, because you know this quantity is going to be less than 4, this quantity is going to be less than 3, so the sum will be 7. But if you had 40, right, I'm just going to show you the method here. So 40 sine alpha plus 30 cos alpha, then you could write it as 4 sine alpha plus 3 cos alpha is equals to 25 by 10, which is 5 by 2. Now, if you were to divide by 5 on all the sides, you will get, you can write this as, let's say, cos of 37 sine alpha.
So ये तो फिर sin ही sin भी बन जाएगा.
Okay, so in that case, you would have sine of 37 plus alpha is equals to half. That means 37 plus alpha would be sine 30, right? So half is sine 30, correct? So this is going to be 30 degrees. That's how you would do it. Now let's revisit our equation, see where we might have gone wrong. So let's quickly revisit the horizontal part. So XA, displacement of A in the positive direction, plus the displacement of B in the negative direction. That should be, sum of the two should be equals to 30. So the equations we have there is 4t plus 10 cos alpha t is equals to 30. Any issues with that one? I don't think that there is an issue with that. Okay. Now let's look at the other one, which is the vertical displacements, right? So to make it easier on the vertical part, let's say the two collide somewhere high here, right? In this case, we know this is YA and this is YB. And can you see the error here? It should be YB minus YA should be equals to 40. Sometimes when you don't really draw things up nicely, we will make. So let's quickly work that out. So YB minus YA is 40 meters. So what does that mean? So let me quickly erase it here. So here we will have YA is this, YB is this. So if you subtract the two, you will have 10 sine alpha t minus 3t equals to 40. Okay. So then our equations will become, so let me erase all this. So from this one, I wrote down t as 30 divided by 4 plus 10 cos alpha. Yes. And for this one, we should have not 3 minus 10 sine alpha, but 10 sine alpha minus 3. Yes, you guys are okay there? ठीक है बेटा, रुचिका, छवि?
Yes, sir.
Okay. So from here, we can then, or we will then have, so I canceled out the zeros there. So we should have 30 sine alpha, 30 sine alpha minus 9 is equals to 16 plus 40 cos alpha. Now, all of a sudden, things have taken turn here. What do we get? So we get 30 sine alpha. So I'm going to say 3 sine alpha minus 4 cos alpha is equals to 9 plus 16 is 25 divided by 10. That means 5 divided by 2. Okay? Yes, beta? Is that right? That is.
Yes, sir.
Okay. So from here, let's use the same approach. So I divide it by, I bring the 5 down here, so leaving only 1 there. So I'm going to say 1 by 2. This is what we have. Okay. So I'm going to call this as my cos alpha term, right? So what do we have then? We will have, or you can call it actually sine as well. It's equally well. So in which case this will be sine 37, or let me call it actually cos. I'll tell you why I'm doing so. Just a moment. So let's say this is cos. So what do we get, beta? So cos of 3 by 5. So when do we have cos as 3 by 5? That will be 57 degrees. Cos of 57 or 53. Cos of 53 is 3 by 5. Cos of 53 into sine alpha minus 4 by 5, then will be sine 53 into cos alpha is equals to half is sine 30. ठीक है बेटा? Okay. By the way, I'm writing angles in degrees here. So what do we get on this side? So we get sine of alpha minus 53 is equals to sine of 30. So what is alpha then? Alpha is equals to 83. Is that right? Alpha is equals to 83. So alpha is 83 degrees. So can I write this as 8 into 10 plus 3? So A minus B. So A is 8, B is 3. Then A minus B would be 5. Yes, Peter? Did you get it?
Yes, sir.
Okay. Let's go back. There are two JEE advanced questions. These questions showed up in 1994, and this other question is even before that. I think it's in 1980s. Both are good questions. You can give them a try. They are definitely good practice questions. Now let's go ahead and go to the next question type. So let me do this. I'm going to skip this one and the next one. I'm going to go to number 40 first, and then we'll come back to these ones. Okay. So what do we have here? So we have particle that is under three-dimensional constant acceleration. So once again, the particle is under three-dimensional constant acceleration. So what do I mean by three-dimensional constant acceleration? Well, the particle's acceleration vector A can be written as some constant I cap plus some constant J cap plus some constant K cap. In other words, the constant acceleration with which the particle is moving has components ax, ay, and az along the x direction, along the y direction, along the z direction. And you might be asked to determine the velocity after a certain time t, or you might be asked to determine the displacement of the particle after some time. So how do we approach that? Well, for the three directions, x, y, z, our constant accelerations are ax, ay, az. So we can use our standard equations. So let's say the initial velocity vector is given to be u is equals to ux I cap plus uy j cap plus uz k cap. This is your initial velocity, okay, at say time t equals to 0. So this is ux, uy, uz. Then to find the velocity after a certain time t, well, I can figure out the x component using the standard kinematic equation v is equals to u plus at. Remember, we can apply these two independent kinematic equations. V is equals to u plus at and displacement is equals to ut plus half at square in each direction wherever we have constant accelerations. So Vy will be uy plus ayt. Vz will be uz plus azt. And I can write my velocity vector at time t as ux plus axt I cap plus uy plus ayt j cap plus uz plus azt k cap. Now let's say you've been given that the particle is at the coordinates x0, y0, z0 at time t equals to 0. then the question might say, what will be the new coordinates, or what will be the position vector after time t? So what is the position vector, by the way, at time t equals to 0? Well, the position vector, let me call it R0, is x0 I cap plus y0 j cap plus z0 k cap. See, the concept is very simple. It's all about getting used to this vector methodology, or getting used to vectors. So how do we find the coordinates at time t? Well, xt minus x0 is uxt plus half at square. Similarly, y at time t is equals to uyt plus half ayt square. Z at time t minus z0 is equals to uzt plus half azt square. So you can then write your position vector at time t as xt I cap plus yt j cap plus zt k cap. Is it clear? I hope it did not seem scary, because it's not really complex. It's just a matter of writing these scary looking expressions, but actually it is fairly simple. Shall we clear that?
Sir, what is that W again? I don't.
W.
Yes.
Oh, sorry. This is my pen has a leaking issue. This is U. This is the initial velocity U. Initial velocity U.
So initial velocity you find. Okay, okay, sir. Yeah, fine.
These are the initial coordinates and initial velocity at time t equals to 0. And we are writing the position vector at time t. And we have the velocity vector at time t. Clear, beta?
Yes, sir.
This is what we were trying to get. So now let's go ahead and solve a sample problem. Looks like there are quite a few questions from JEE Mains. So let's quickly solve all these 7 questions or 10 questions, and then we'll move on to the other questions. Please start with this one. Even though the question could have been more explicit, the question could have said that we are talking about the or the particle is at the origin at time t equals to 0, or they could have said the relative position of that object from the launch point or from the starting point is ai plus bj cap. But for right now, assume that the particle was at the origin at time t equals to 0.
इसे 2 आ रहा है.
Yes, sir, 2 hour.
Wow, you guys are quick. That's good. It's the same question. Oh, similar question. Similar question? Yes? Yes.
Yes.
Okay. Again, the same question.
Sir, इसमें variable force आ सकता है क्या?
Yes, you can get the variable force, but then remember the techniques we use to deal with the variable acceleration, right? If the force is given as a function of position, then recall what we did if we had acceleration as a function of x, right, Peter?
Yes, sir. हाँ.
Or we had acceleration as a function of v, or acceleration as a function of time t. How did we approach when we had the acceleration as a function of position? So we wrote down the definition of acceleration and velocity, and we eliminated time t because we don't need time t in that case. So let's say acceleration is given to be a function of position x, ax, right? Then ax is dvx by dt. And what is vx? dx by dt. If you divide the two, what do you get? ax by vx is equals to dvx by dx. So which means I can write ax dx is equals to vx dvx, and we can integrate. This is completely a function of x. This is completely a function of vx. Okay, so this will simply be vx square by 2. Initial conditions, final conditions, and whatever the function is, we can integrate that from the initial position to the final position. That's how you would approach that. Okay.
Okay, yes, sir.
I'm trying to find something that is unique and interesting. Again, u is given, constant acceleration a is given, the x coordinate of the particle at the instant when its y coordinate is 32 meters is d meters. Okay, then the same thing. They're saying find out the x coordinate when the y coordinate is given to be 32. So now they're not using the time thing. They're not saying displacement after time t, but they're saying displacement when displacement in the x direction when the y direction displacement is 32. Do you guys want to quickly give it a try? Let's go ahead and solve this one.
सर 60 आ रहा है.
Oh, have I made a mistake here?
Yes, this is 60 आ रहा है.
60, yes. You're right. This is 3 into 20. Okay. Let's move ahead. Similar thing or same thing? Not interested? Now, instead of distances, they're talking about time t in which the y component of the velocity becomes 0. So we'll just use the equation v is equals to u plus at. Let's quickly go ahead and solve this one and then we can move.
So 40 आ रहा है.
Yes, that is correct.
Yes, this is 40 आ रहा है.
And this is definitely a slight tinge of the same thing, but let's go ahead and solve this one as well. Just in the spirit of making sure we are not leaving any grounds uncovered or not covered. So let's go ahead and solve this one.
And minus 1.5 J.
Yes, sir.
So you guys have figured out the time t, 3 seconds,
Yeah.
and we are interested in finding the y coordinate. Oh, sorry, the magnitude of its velocity in the y direction. So vy, uy plus ay t. So we know uy, which is 0. So simply ayt, which is minus 0.5 into time is 3, minus 1.5 meters per second. That's what you guys said? Yes, Vida?
Yes, sir.
Okay. Now we're going to look at two scenarios involving projectile motion, wherein the projectile is thrown from a platform that is either moving with a constant velocity or accelerating at some constant acceleration. So in number 38, we will have the platform accelerating with certain acceleration, and in number 39, we have the platform moving at constant velocity. So let's start with number 39, and then we'll look into 38. Okay. So now what you will be given is, in such questions, you'll be given that the platform is moving, let's say, horizontally towards, let's say, right side, which we may call as positive x direction. So let's say it is given that the platform is moving at constant speed v towards right. And then you might be given the relative velocity and the relative projection angle as seen by the observer on the platform. So what you'll be given is that the man on the platform releases the ball at an angle of 30 degrees with a velocity of 5 meters per second, right? And you'll be asked to determine the distance that the ball travels, or rather, I should say, for example, in this scenario, it has been given that the projectile, when it reaches its maximum height, then it hits another object at that point. So we are interested in, at the highest point, the particle only has a horizontal velocity. So we are interested in knowing the component of the horizontal velocity, right? So how do we figure that out? Well, with respect to the platform, the launch velocity is 5 meters per second and the launch angle is 30 degrees, correct? With respect to ground, what is the launch velocity and what is the projection angle? Well, we know the relative velocity of A with respect to B is VA minus VB. In this case, what is B? B is the platform. So velocity of platform with respect to ground. And what is VA? In this case, speed of the ball with respect to the ground. So what is V ball with respect to the ground? It is V platform plus V relative. What is V relative? Or I should say the relative initial velocity, that is 5 cos of 30 I cap plus 5 sine of 30 j cap. And what is the velocity of the platform with respect to the stationary observer on the ground? That is, let's say it is given to be 10 meters per second. So in that case, it will be 10 I. So then the velocity of the ball with respect to the ground is 5 cos 30 plus 10 I cap plus 5 sine 30. So if somebody were to say, hey, what is the projection angle as seen by the observer on the ground? Now the observer says that the initial launch velocity is such that this component, which is Vy, is 5 sine 30. And the x component is 5 cos 30 plus 10. So what is this angle alpha? Well, tangent alpha is 5 sine 30 divided by 5 cos 30 plus 10. Is that correct? Did you guys understand it?
Yes, sir.
Okay. Give me a second. Let me just pick up a question from YouTube. Just give me a second. Okay, so we have a question there. So let me understand it. So Gagan, you can explain from starting. So beta, can you just help me understand? Are you referring to this particular question or are you referring to something else, beta? By the way, you should be able to go a few minutes back in your video. So you have that option on YouTube. So you can actually go back in time, understand what we're talking about, and then you can throw your question at me if you have specific question, beta. Okay, so I'm going to go back into the live class, and if there's any question that comes up from your end, I'll definitely address that. Okay, Chavi, Ruchika, beta, absolutely clear?
Yes, sir.
Okay, so let's go ahead and solve a sample problem if we have one here. Let's go ahead and solve the anti-abhyas question. Let me read through it. It says a horizontal smooth square platform ABCD square platform is moving towards the right with a uniform speed v. At what angle theta must a particle slide from A on the platform with a speed u so that it strikes the point B? So that it strikes the point B. Looks like they are talking about this u with respect to the ground. Okay, for the students of the YouTube, the trick is to uh, figure out, or the trick is to realize that the distance in the horizontal direction covered by A should be the same as the distance covered by B. Now, in the same time, the particle should also cover the vertical distance or the distance towards the in the upward direction or towards the B in the same amount of time, right? So, but the component of the velocity of u along the right direction should be the same as v. Otherwise, they will not be able to meet with each other. As simple as that. So can we have a quick discussion, beta? Chavi, Ruchika?
Yes, sir.
How are you guys thinking about it? Okay, so let me ask this question. Let's say in the horizontal plane, this direction towards the right is x and pointed towards the, let's say this is x and this is y. By the way, both x and y are in the horizontal plane. Okay, so towards the x direction, should u cos theta be equals to v? If yes, y, if not, y. Should u cos theta equals to, that is the component of the particle's velocity along the x direction is equal to the velocity of the platform in the x direction.
Yes, sir.
Right now?
Yes, sir.
Only then, when the particle reaches here, B would be here. When the particle reaches here, B would be here. When the particle reaches here, B would be here, right? And then they meet. Correct, beta? So both are covering the same distance till they meet.
Oh, okay. हाँ, sir. हाँ,
Right?
yes.
So u cos theta must be equals to V. Now they could have asked us, well, in fact, let's see if they could have asked us they need to give some other information, and they could have asked us to figure out this dimension, right? If they meet after a certain time t, then what is the size of the platform? We could have done that as well. But anyway, so here u cos theta is equals to V. That means cos theta is V by U, or theta is cos inverse V by U.
Yes, sir.
Okay, good. Now let's go ahead and look at the last question type for the day. Here the platform is accelerating. Okay, platform is accelerating, and let's pick up an interesting question from JEE Advanced. But the question is that the platform is moving, accelerating in the horizontal direction with some acceleration, and the man launches the ball with a relative velocity, and then how far behind the man will the ball fall when the ball again hits the train? Something along those lines will be the question. Would you guys know how to figure that one out? Right? How would you think about it? Well, let's say that the train's velocity at that time t equals to 0, when he releases the ball, is u0. And we have been given v relative. So now we can figure out the x component, which will be, let's say this angle was theta, relative angle was theta. Then with respect to the ground, the horizontal component would be v relative cos theta plus u0. Right? The vertical component with respect to the ground remains the same, that is v relative sine theta. Now it's a matter of just doing the simple, just simply write down your equations of motion. Now for the platform, it will be x distance covered in time t would be u0t plus half a t square, where a is the acceleration of the platform in this direction. Yes, Peter? Clear? And how would we find the time t? Well, that'll be determined by the time of flight of the projectile. And what governs that? Well, that is governed by the vertical component alone, right? So how do we do that? So we say, so when it comes back, the net displacement will be 0, uyt. minus half gt square. Uyt is v relative sine theta. So v relative sine theta times 2 divided by g will be your time of flight. So you know t, so you can figure out where the man would be if he does not move relative to the platform. So where will he be after that time t when the ball lands back? And you can figure out the distance covered by the ball in the horizontal direction, which will be v relative cos theta plus u0t. Is that part clear, beta?
Yes, sir.
So we have this, and we have this. We should be able to find xt minus x ball or x man minus x ball when the ball lands back onto the train. And that way we'll know how far behind the man has the ball landed in this case, or how far ahead of the man the ball has landed, either way. Chavi, is that clear, beta?
Yes, sir.
Okay. Good. I think we are done with our the intended target. So we only have 2 question types left, which we should be able to cover nicely tomorrow, and that'll be the end of this chapter, kinematics. Now, just want to point out a few things, Chavi, right? So, but there is a reason we have adopted a certain approach when we are doing the class. No, I'm explicitly pointing that out so that you understand it. First of all, the pace of the class is quick. If you see it from a third party standpoint, the amount of coverage is fairly good, right? But the pace does not seem that quick when we are doing the class. Why is that? Because I am talking slow and I'm talking at a fairly low energy. Question is, why do I do that? Right? The reason is, if I talk with high energy, then you will say yes to everything I say. Everything I ask, you will say yes, sir. But that's what's called a forced confession, right? Someone in the authority says, "Ye kaam karoge?" And you say, "Yes, we'll do it." Right? "Ye hua?" "Yes, hua." But actually, the mind stops thinking about the question. Right? Mind is not intellectually engaged. So that's why I try and maintain the pitch and the speed so that you guys can think independently, right? Because the whole idea is to build the ability to solve questions. You get Chavi beta? This
Yes.
will not be my normal demeanor when I'm in say meetings with my peers or things like that nature. But I very consciously adopt it, and I always pray and request all teachers to do the same. Everybody seems to be talking at very high energy, right, during the classes. But whenever the teacher adopts high pitch, high this thing, your mind does not think, it just follows. That's why if you notice, right, Ruchika? So when you are in Akash, you are, most of the time you are simply taking notes. You think that you will go back home, then think about what the sir has said.
Yes.
But the speed is never high in the class. The amount of coverage is not that much. It's just that people have become used to shouting at. I don't know why. It is what it is. It's not we're not trying to make soldiers out of soldiers, yes, but different kind of soldiers, thoughtful soldiers, not the ones that will obey orders blind, right? But in any case, let's take a quick 2-minute break and then we'll switch over to organic.
Sir,
Yes, Peter.
sir, today in school, we just got a schedule for a new type of the online class for centum.
Okay.
उसमें evenings में class है, तो mostly I won't be attending the chemistry and physics one because this is mostly revision, so I'm good at that. So chemistry physics में problem नहीं है. But sir, math wala I want to attend, and that is Monday evenings.
And when is the math wala class?
Sir, I think it's about 6:30 to 7:30, 7:38. So I think physics वाला fit हो जाएगा, but chemistry वाला में problem आएगी शायद.
So we'll see. So what we can do is we can pull 15 minutes ahead, perhaps. Right? And
Yes, sir.
yeah, we can make some minor adjustments here and there. Okay, so let's quickly change gears. I'm gonna turn off the streaming here. Give me a quick second, and then we'll switch to our chemistry.